Now for the grand finale, our closing keynote. While AI ML was born in the data center, where it will be truly transformational is at the edge. AI ML is the only way to keep up with infinite streams of machine data at the edge. The closing keynote will be moderated by Ken Mills, who serves as the Chief Executive Officer of Epic IO. He is a member of the Forbes Technology Council. Our keynote speaker is Dr. Sudhir Srinivasan, who is the Chief Technology Officer for Storage Division at Dell Technologies. In his role, he is responsible for coordinating the technology strategy across the storage product portfolio and driving innovation everywhere. Sudhir is a 21 plus year veteran of the information infrastructure industry with particular expertise in scalable storage architectures, where he has authored many patents. He holds a Ph.D. in computer science. Over to you, Ken.
Thanks so much for having us, and thanks, Sudhir, for allowing me to participate in this event with him. Sudhir and I have become good friends over the years and highly respect him. So if you get any time to spend with Sudhir, you will find you're in great company. It's great to see that video, Sudhir, and really get a feel for how people are kind of making real the use of edge computing, from a drone to artificial intelligence to storage, and bringing all those things together in what has become known as the intelligent edge. So I'd love to get your thoughts on, how we make sense of all of this intelligence at the edge, and how we connect that to AI and ML for the folks here listening.
Yeah, thanks, Lalit, and thanks, Ken. It's great to be with you here today, and thanks, Ty, I think, for this fantastic event and audience here. Really appreciate the opportunity. Yeah, edge is a lot of things to a lot of people, as you and I were talking about. So many definitions, whether it's wearables or sensors on remote windmills or whatever, all the way to maybe it's an IT closet in a remote or branch office, or even a manufacturing facility, etc. So I think of it more just quite simply as anything outside the data center. We've been living in the data center for so long, and it's really, the world has moved out from a data point of view. And the thing, I'm just going to share a screen here for some data points that I'd like to share with you guys. I think this is the right one. Y'all can see the screen now. Can you see my screen, Ken?
That's right. I can see it.
Okay. I think why is there we go. The thing that's important, or the most relevant thing about the edge is these, in fact, the data, right? And Gartner has predicted about a couple of years ago that 75% of the data that's going to be generated by 2025 is going to be outside of the data center. And that's just dramatic. And the reason is it's all machine generated, right? And there's these devices, whether they're sensors or drones or cameras, whatever it is, generating lots and lots of data. So there's two things that stem from the fact that it's machine generated. One is the sheer volume. And if you're following all of the IDC data sphere type of measures, there's so many ways to look at it. I think they're saying the next 3 years is going to produce more data than the last 30 years, and other ways to slice that. The bottom line is just going to be an explosion of data that is really not possible to deal with any other way other than automation. And then the second aspect is that because it's machine generated, there's the need for speed and low latency. It's real time in nature. You need to process it and extract the value from it instantly. And gone are the days of sort of doing it in a batch style processing and doing analytics that way. I mean, there's still room for that, but this is a new wave of analytics. And so if you put those two together, the only way to do that effectively is using AI. And that's why the edge has to be built around AI from the beginning. How do you see it in your world, Ken?
Yeah, kind of. We live in that OT world, and we play in all the edges kind of outside the data center, and And we're seeing more and more demand from our customers to process more and more data and more different types of data across IoT sensors to video data to trend data across both those types of sensor sets. And the need and demand is not slowing down. And the responsiveness needed for our customers is only increasing. So, one of the things I get excited about is when we get to work with big companies like a Dell or others, where we can leverage technology and investments you guys are making to make our jobs easier. It allows us to scale solutions quicker and deliver solutions quicker for our customers. So, specifically, how is Dell really helping customers and partners and folks on this session really enable that data streaming requirement around the intelligent edge?
Good. Yeah, good. So good question. We sort of started looking at this space, a few years ago. Obviously, being a storage company, infrastructure company, the growth of data was very, very attractive, very interesting. So we started looking at it about 4 or 5 years ago. And one of the first things we looked at was, okay, we're used to dealing with data, unstructured data, with file and object semantics, but there's this new class of real-time data, streaming data, that's come up. We call it streaming data or streams. That's sort of fundamentally changing the way analytics was being done. And what we saw when we looked at the industry was, it was early adopter days in those days. And we sort of looked at all the big shops, especially the digital natives, right, born in the cloud companies. So what we saw was a few challenges that were coming from the rapid rise of streaming analytics, streaming data. One was that, just as we talked about, the need to move fast. And so that means there was a lot more distribution of compute and storage to process wherever the data was being generated. That caused a more siloed approach where, people were just getting things stood up as they needed it. That then led to, inconsistencies of data across all these silos, which led to wrong conclusions, algorithms getting confused because of inconsistent data. And that caused application development to get more complex because now you have to manage across all these silos. From an infrastructure point of view, we also saw that the first few attempts at doing this in a scaling way were pretty rigid and rudimentary. Basically requiring manual scaling or designing for the maximum peak and things like that. And then finally, there was also a lot of, obviously, security complexity because of just the inherently distributed nature of this world. And so we saw there an opportunity to sort of help our customers, especially those who don't have all of this expertise to do it themselves, to sort of really come out with a turnkey solution that allows them to just focus on the analytics. And that's what we call the streaming data platform that we launched last year. And that was in the video that you just saw. And so idea here is that, not only do we do the storage, we now also integrate it into this platform is that high-speed real-time ingestion, highly scalable ingestion capability, as well as the analytics platform to allow you to do whatever analytics that you want to do, whether it's AI, ML, or something else. Both real-time and batch discrete analytics as well. And really, the primary, it's all software defined, right? This is entirely a software thing, and it's deployable in many form factors, whether it's at the core data center or at the edge, as you saw in the video. So we can deploy it on very low-end devices at the edge, as well as in very highly scalable infrastructures. But the point of this for a customer, what this does is allows them to focus entirely on the analytics, on the AI ML that they want to do, versus worrying about the infrastructure. How is it going to scale? Is it going to be consistent? Am I going to have data loss, et cetera, et cetera? So, I don't want to get into too much of the nitty-gritty here, but I just want to give you a sort of quick sense of what we did, how we built this. The core of this is the streaming engine, and that's a capability that we call Pravega. Pravega is actually a streaming service that we built from the ground up. And to build this, we sort of took stock of what was out there in the industry and sort of designed it to address all of the challenges we were seeing in the state of the art. Things like dynamic scaling and touchless scaling and distribution, and plenty of other things. And this was actually done as an open source project. It's out in the CNCF project list, and we're obviously still very much active in this space. And in fact, we actually conduct a hackathon every so often. And if you're interested, I would encourage folks to take a look at provega.io. And we have our hackathon coming up in I think in a week or so. Really encourage you to join. But the idea is that's the core engine. We have the storage piece underneath it, both for active tier and as well as our long-term storage. And then on top of that, we have layered all of the analytics engines, whether it's just stream processors or even more sophisticated AI ML engines that are available. So that's kind of what we see it. What about you? What do you see in your space?
Yeah, I mean, for us, the democratization of compute and inferencing and being able to deploy that in so many more locations and be able to pull data from so many different sensors and do it much closer to the machine or the data set that's being originated from has really driven a ton of different use cases. But it still hasn't solved the fact that you need to process that information as quickly as possible. You still need to often connect the edge with the cloud together and leverage the storage and scalability of that storage and all these different services that you're talking about. But just because you put compute at the edge, it doesn't abstract away the need to still leverage these set of services to really get that value long term out of that data. And that data is always coming, right? That's one of the things that's unique for us and that we always have to kind of explain to our customers is this data is running 24/7 and it's not stopping, it's not waiting, it's not only coming in, off hours, it's coming in all the time, real time, and you need to be able to respond to it real time. So it's really caused a lot of challenges in how to scale this data across major deployments where you have thousands of nodes or thousands of sensors that are generating this data simultaneously. So leveraging a platform like Streaming Data Platform really helps us scale that solution. So, how are people using it? I'm talking at it, I look at it from an edge first, and you're looking at it as well, at the edge and bring it together. So how are you seeing other folks leverage this technology truly at the edge?
Yeah, this is a new area for us also at Dell, and we've been, over the last year, been building up, some really fascinating use cases for this. Just in all kinds of verticals, right, or kind of different use cases. The most common one I think that everyone probably relates to very easily is the connected car or autonomous vehicles, more generally speaking. And I think there's been, while we all talk about sort of the connected car and the autonomous driving use case, there's actually been a far more progress, I would say, in terms of effectiveness in more targeted applications of this concept, such as in a construction site that you just saw, where it's relatively easier for these vehicles to operate because they're fixed, relatively constrained environments. We've also seen it in things like theme park rides, for example, or airports. Anytime you have a vehicle that's coming into sort of a base station and downloading all of the telemetry that it's collected, and that needs to be processed in really short amount of time in order to be able to maybe detect safety situations, or is this device ready for another run, in your turnaround times is in order of minutes in the case of those rides, or tens of minutes for things like airplanes or trains and things like that. So that's kind of the most typical use case, is where you've got these end devices that are submitting the telemetry. We're doing the analytics, inferencing at the edge to provide the real-time feedback right there. But at the same time, the data is also being processed over much longer time horizons to train models and build newer improvements to the models. And that's then fed back into the devices at the edge as the models get updated. So this is, and then at the back end of it, over the longer term time horizon, there's more analytics done. And that's where the streaming primitive really becomes very helpful, is because you can run the same models on current data, on historical data. You can rewind your back to any point in time and rerun your new model, try out a new change to your model, and run it at any point in time in your stream. And those are the kinds of things that we're enabling through this. And we're seeing it in a lot of across the board. Like I said, drones. We saw the drones, the cameras, the stuff that you're doing with Epic and IntelliSight, and then just in general sensors and various types of verticals like manufacturing for sure. So there's a lot of different applications for this.
We've started to see an uptake in transit systems and trying to bring a lot of intelligence to the transit system. We talk about airports, right? But trains, buses. Anytime there's a whole new kind of renaissance in digitalization and innovation going on in transit overall, and not just the autonomous car, but all the other adjacent technologies. So I see this playing a big role as we go forward and really providing better automation, safety, and just real uptime and set of services that are delivered across these different transit environments, whether it be airports, trains, buses, or anything between.
Yeah, maybe it might be useful for the audience. Maybe if you want to talk a little bit about your smart city or one of the specific use cases you have that's perhaps a little different from this one.
Yeah, we're seeing a huge resurgence in intelligent traffic systems to kind of prepare for these autonomous vehicles, and how cities are going to be able to bring the data from all the different traffic sensors that exist and then connect that data to all the autonomous vehicles that hopefully will be traveling throughout our cities in the near term. So we're working with quite a few cities to really digitize and bring forward all of that data and use the cameras that are looking at traffic systems and using sensors and all those things to understand things like what kind of near misses are happening. So what kind of accidents are not being reported but almost happened, and how do we improve our traffic movement across our city to reduce those near misses, or how do we reduce pedestrian fatalities to zero, or how do we interact with pedestrians that are now more distracted looking at their phones, which I'm guilty of, as you cross the street, and make sure that, hey, you let people know that a car is coming because you're crossing the street in a non-safe time, or a car is not paying attention because they're looking at the phone and there's someone in the intersection trying to cross the street. How do you communicate to both sides of that equation to reduce pedestrian fatalities down to zero, or as near zero as possible? So those are types of things that we're starting to see that are really compelling for not only the cities themselves, but the constituents who are now moving largely to urban populations as we go forward. And all studies say the urbanization is happening in a big way everywhere.
And I think that's great. I think the COVID pandemic clearly just brought a big spotlight on this whole, accelerated this whole space, right? I mean, we're seeing all kinds of use cases related to contact tracing, safety, security, et cetera, as well. And I'm sure, hopefully we don't have another pandemic like this, but it's likely we will. And I think we'll be better prepared the next time. I would say.
Oh yeah. The kids will be experts at it, right? They can do all that remote learning that they've come to love, which is completely untrue. So, kind of switching topics here, just for the last handful of minutes, and trying to keep on track. Entrepreneurship is a big deal, and we'll kind of wrap it up with one question as the grand keynote is about to start. How is Dell helping the folks that are attending this session really embrace innovation, entrepreneurship, and kind of take advantage of what Dell has to offer?
Sure. Thanks for asking. So we do a lot. We have a program called Dell for Entrepreneurs. We can certainly help startups get started with lots of different ways to help, like program help, technology help. But I think the real benefit of working with Dell is also, as you said, as in you yourself have experienced, is the relationship and the ability to leverage our reach as a company and for your technology. And so we constantly look at startups. We have been a very acquisitive company in the past. We have done some innovations at home, but we're also continuing to look at acquisitions as well, and always looking to partner with startups to in technologies that benefit us.
Yeah, just in wrapping up, as someone who's worked directly with Dell in that facet, as not really, we've been around for a long time, but we've really been innovating a lot more, and we kind of look at ourselves as a second gen startup. Dell's been a great partner in helping us scale and bring our technology to a broader set of customers and partners, and really help us enable our technology and enable outcomes for our joint customers. So it's been a great partnership with Dell, and we're very happy to be a part of it. And thanks, Sudhir, for the time today. And I know we didn't get to hit every topic we hoped, but really appreciate you taking the time out of your day and sharing some thoughts with us.
And thank you, Ken. Good to see you again as well.
All right, you too. Thank you, guys.
All right. So Sudhir and Ken, that was a perfect way to end our AI/ML track. Edge data processing and AI intelligence, including scalable and software-defined storage architectures, is going to see massive growth. And again, thanks for bringing up how startups can use Dell technology offerings to grow.